right, last week we left off talking about LANs versus WANs. Okay, looked at this wonderful picture. Okay, let's continue on. Now let's talk about the elements of it. First of all, we've got a client. So what type of clients do we have in this room? Anybody? We have desktops, we have some laptops, we have some mobile devices. Could be a printer. It really is anything requesting a resource. Okay.
Switch.
Yeah, it could be a switch. Yeah, well, okay. I mean, see, the problem is none of this stuff is clear cut. Remember how we talked about the distances where a LAN and a MAN and a WAN? There's really no clear cut. It's basically it's anything that uses it.
I guess if you install it for the first time, it's going to require that IP address.
That could be. But you also think about it, it could be another machine. Because now a lot of stuff is automated. Okay? So when you guys enroll in classes, I don't know if you know how the system works, but if you're brand new, never been to Rose State before, and you enroll, you go to admissions, you're not in the system yet. I don't know if you realize that. It takes them a while to put you in the system. Then you're in partially. At midnight that night, you get an email address. And then once you enroll in classes, at midnight that night, you get D2L access. So some people think I go to admissions, I'm in the system. Well, no, you're not. Because they put you in, but then it's a batch job every night at midnight to get the email addresses set up. At midnight to set the D2L account set up. So there's, but those are done automatically. So you can kind of think of those as clients because they're doing stuff for us. Okay. Could also be software installed. The server is what responds to these requests. It could be a printer, a print server. It could be a file server. It could be whatever. Okay. Run some sort of network operating system. So what do you think network operating system that camera runs up there on the wall? Anybody?
Network operating system?
What type of is it a network operating system? Well, it's responding. I mean, does it meet the requirements of it? It's giving us a resource.
Has an IP address.
Has an IP address. We're connecting to it, so you can kind of consider it a server.
Remote into it.
It is. It's a web server built into it. It's actually a Linux-based web server. So sooner or later in this class, we're actually going to be scanning the network. You'll see a bunch of machines with HTTP and FTP open. Those are the cameras. So we can connect to the web IP address of the camera. We also get a workstation. This is the personal computer. You used to be able to buy workstations. Now you just buy a machine. I mean, they change the way they do that every now and then. Okay? Network interface card. I do not have one to show you in here. But that's the thing in the computer, which we'll see a picture of, I think, on the next slide. Yeah. But it's what we connect with. Okay? It's what connects us to the network. And we'll look at the picture in a minute. It's the device inside, connects to this cable, and allows us to get on the network. Without that, can we get on the network? If we have wireless, we could. But we also have wireless network cards. And remember, we could buy a computer without a network card? Nowadays, they're... Exactly. Everybody has one. I remember years ago, you buy a laptop without a network card. It actually had a connection for it, but there was no card on the inside. Yeah. We actually rebuilt the iPad 2 down in my office. We had one that couldn't charge it anymore. And the home button didn't work. So what's the problem? Anybody know? Actually, the connector popped off. But in opening it, Roy decided to smash the screen. So removing the screen the rest of the way, he sliced through the Wi-Fi antenna. So you can see how this is getting more and more expensive as we go. But it's all fixed now except the tape hasn't come in yet. Because it's funny, the iPad 1 and iPad 3 are held down by clips. iPad 2 is taped on. What the hell? I think they did one, then switched to 2 and said, ooh, we're going to try the tape. And said, God, that was a stupid idea. Let's go back to the clips. And he was following the video from the iPad 1. Smashed the screen. But they were going to charge me $70 to fix the connector anyway. I bought all the parts for $42. So I'm saving a little bit of money. But it sucks that it was just a little connector popped off. But the Wi-Fi antenna, teeny tiny little thing. It's a little teeny piece of wire. It's like, you got to be kidding me. That's all it is. I mean, it was one of those things you put in your hand, you couldn't even feel it. It was that light. It was a teeny tiny little circuit board, so big, a little wire hanging off of it. Like, you gotta be kidding me. So it was kind of crazy how small those things are now. Okay, so we have a device connects to the media, allows communication with other computers. Okay, the network operating system, that could be Server 2008. It could be Linux. It could be Mac OS X. It could be Novell, Ubuntu. It could be a whole host of them. There's tons of them out there. Okay. Enable service to manage users, data groups, files, printer, all that kind of stuff. Okay. All right, here we go. We have our motherboard. Okay. I was actually had lunch with my son today at lunch, and he just moved here from Arizona. I mean, he was here, then he went to Arizona, now he's back. And he had a problem with the computer a couple months back. And I was trying to walk him through fixing it, and it wouldn't boot for nothing. I mean, he upgraded the RAM and upgraded the processor and wouldn't do nothing. It was totally dead. What the heck? Well, he plugged the memory into the wrong slot. How did you do that? He said, I couldn't see what he was doing, but, you know, memory goes up here, if you didn't know that. Power goes over here. Network card connectors here. Now, this is a built-in network card. Okay, are those better? What do you think? Integrated or?
Well,
see, we have integrated video.
if your NIC gets fried by a lightning storm, you have to buy a whole new board.
Right. Here we have integrated video, integrated network card, integrated USB, integrated serial, I'm assuming. If we lose the NIC card, guess what? We're done. Right. Actually, we had one, had a Chapel Supply, a client of mine that I used to have, had the weirdest issue. Every night at midnight, they would lose network connection to the server. Or actually, no, the backup would quit. That's what it was. The backup would quit. And I ended up putting a machine on there, recording connections to the server all night long. And every night at midnight, it quit working. It would basically lose connection to the server. And that's why the backup would fail. The server lost connection to the network. It had an integrated network card. We tried everything. I got on the phone with Dell, and they're like, we figured power management or something. Couldn't figure it out. So they shipped me a PCI network card. Dell was like, okay, you know, you have an integrated network card. We can ship you an entire motherboard, or we'll give you this better quality PCI card. No, please send me just a PCI card. I don't want to tear down the whole server. Fixed it. So whatever it was on that one card, every night at midnight, went offline. Come back on a little bit because the morning was on. It was weird. But this is an integrated network interface card. Okay. Plug right into it. What type of connection is that? Can anyone see it? Cat5, RJ45, Cat5, Category 5. Or could be Category 5E. Could also be 4. Could be Cat6, not 7. 7's a little different. I have Cat6 in my house. The only difference between Cat5 and Cat6, we'll actually look at, we're going to be making cables in here, is there's an actual, it looks like a, what are those plastic things that were twisted, like pipe cleaner kind of twists on it? But it does it to keep the wire twisted the correct amount of times. Yeah, the more twist, I mean, it keeps it uniform. But we'll look at all that when we make cable. I think we do that in chapter 3. I don't know, something like that. We'll look at that. Okay. Hope it's not tonight because I'm not ready. Okay. All right, we got a host. That could be a computer. Okay, enables a resource. We could have a node. That could be something on the network. Some sort of connectivity device could be our switch. Okay. The different types of switches out there? Sure. This switch costs $100. Okay. Then how come I can get the same switch for $3,000? Anyone know why? I mean, I can get the same type. So why would there be a difference between $100 and $3,000?
Firewall, bandwidth for each port.
Actually, some do support firewalls, but normally it's bandwidth or management. Like this switch is an unmanaged switch.
You can't remote into it.
Right. You can plug it in and use it. With a managed switch like we have down the hall, we can actually turn switches on and off. We can upgrade speeds of them. When I used to work at an ISP downtown, we used to sell DSL. Y'all know what DSL is, some of you? Digital subscriber line. It was high-speed internet before we had cable, pretty much. And it was funny. We would sell it. You know, so much for this speed, so much for the next speed, so much for the next speed. It was funny because obviously if you got the higher speed, we would charge you more money. I wouldn't charge you, but the company was. I just did the work for them. But man, the only difference in it on my end was I go into my router and basically say instead of 512, you get 768 or 1024. And what I would do is if some of mine was having issues or something, I just keep upping their speed, keep upping it and upping it. And no big deal on mine. And I actually had an issue with my Cox. I live right off of I-40 and Choctaw Road. I run that addition over there. And we had just DSL for years. Actually, initially I had no DSL even. But Cox would install cable out there for nothing. They said, yeah, as soon as they finish the addition, we'll install cable. They never came. They finished the addition, they never came. So I contact Cox. Well, it's not available in your area. Sorry, we're not going to do nothing for you. So a guy used to work over here, Grant Cadis, lived off of 15th near Anderson, and they had cable on one side of the street but not on the other. He called Cox and like, well, it's not available in your area. Sorry, we're not going to do anything for you. So he contacted Gary Bands, a representative for Oklahoma. Next week, Cox was installing cable in their neighborhood. I contacted Gary Bands. I got a personal note back, handwritten from Gary Bands. Sorry, Ken, I contacted Cox. It's not available in your area, but they are going to see what they can do. I'll be darned. 2 months later, install cable in my neighborhood. It's like, sweet. And they did it over Christmas time. But, I expect, you picture someone digging up the entire neighborhood over Christmas, what's going to happen to the yards? Look like crap. You couldn't even tell when they were done. They would literally cut out huge squares. When they were done, if you look real close, you could see it. But it was perfect. I couldn't believe they did it so well. But, I have no idea where I was going with that, but basically, how you're connected. Oh, that's right, the DSL. When I had Cox installed, they came out to install it in my house. I was actually the first one in my neighborhood to get it, because obviously I want it. So the moment I saw them digging holes, I called them up, and they couldn't get it to work, so they run out to the truck and get a different cable modem. I don't know. So they keep finally they got one that worked, but it keep getting slower and slower until I had to reset it. Then it would get slower and slower until it was like basically unusable. And finally got them on the phone one day, and they're like, "That's weird." So after numerous troubleshooting calls to them, what they were doing is they would keep upping my speed. It's not working. I said, up it somewhere. It's not working. So they're like, "Well, I don't know what that is. We'll just send a technician out to look at it." Well, I said, "I know what the problem is. You gave me an old crappy cable modem." So I went to Best Buy and bought one of the new, I think it's DSC3 cable modems, whatever the acronym is. I brought it home. I had a 100 megabit connection. It's supposed to have the 20, but they kept upping it. And they never now it's finally lowered again, but it was that way for months and months. I bought a new cable modem and fixed the entire thing, but it's kind of funny how that works. But connectivity device, how are you connected? Okay, do you have a switch? Do you have a router? Do you have a hub, which you really can't find anymore? Okay. All right, segment could be a group of nodes. So we have a network segment in this building. We have backbone or fiber coming into the business building, hits the main switch down the hall. If you ever want to see the switch, the next hallway going to the right, the second doorway has a window on it. Look in the window. You'll see all the switches on the cables. The entire building connects into there. So every port, let me fix that. With the exception of the cybersecurity labs. We do our own. But if you go in like room 202, 3, 4, 5, 6, 8, 15, 16, all those other rooms, plus all the rooms downstairs, they all connect directly into that room. So even from my office, where my desk is, there's a cable running up, all the way down, up through the maintenance closet, and then back down to the switch. It's a home run, they call it, for every one of the connections. So it works pretty good. But a segment is a group of nodes, so we have a business division segment. Uses the same channel, and we're all connecting into the same switch. Okay. The backbone is normally a higher speed network connecting these segments together. Okay. It's like we have fiber between the buildings, so it's very fast. Okay. Topology is the layout. Is it a ring, a bus, a star? And we can see pictures of all these here in a minute. Okay. Does anyone know what topology we have in this room? A ring, bus, or star, just in this room. It's a star in this room, yeah. In Rose State in general, it's a hybrid. But in this room, we all connect into this switch. So you can think of the switch as like the central area and going out to all the computers. So in here, it's just a star, okay? I've worked on buses and stars. Rings were popular, but then they started getting replaced. I remember when building 3001 at Tinker, y'all remember that building? I actually had ArcNet installed in there because I helped install it. You were limited to 254 hosts on it. It was through ThinNet, which looked kind of like coax cable. Yeah, it was fun. And everyone had a specific address on each port. It was
still out there too, right?
They still have it?
It's not used, but the cabling and all that's still there.
Actually, they're downstairs in our office. They're redoing one of the walls in the main office and moving the doors and stuff. Up in the ceiling, they got this huge gray wire running all in the ceilings. It's the old telephone and clocks. See, well, they painted over this one. But where that fire alarm is, there used to be a clock there and an intercom that was down to the main office. But all those wires are still there. It's when I took care of Taylor Valve Technologies Network, who kept installing stuff for them. Finally, one day, I said, dude, you got like so much old wiring in the ceiling. So they paid me to remove it, and it was, you wouldn't believe the amount of, just tons. Because what happens, you always install the new stuff. And there's like all this old crap up in the ceiling. So, all right. Here we go. This is a switch with some clients connected to it. You can think of maybe this is the business building. Then this is the backbone connecting to a router or maybe to another building. And then maybe we connect to another building over here. You can have multiple. There's actually, I don't know what the book talks about. It's called the 5-4-3 rule. Your network should have no more than 5 segments. Okay? With connected by 4 connectivity devices, like 4 routers. And only 3 of the segments can have computers on. Only 3. It's one of those deals. Like, does anyone know how long this cable can be? 100 meters, approximately 300 feet.
300.
So does that mean at 310 feet it's not going to work? How about 400?
No.
I've seen it work up to 600 feet before. Way back, if you go in at Tinker, right off the air depot gate, there's that huge field. They actually had a connection going over 600 feet there. But I mean, there was no interference with nothing, and it was just 2 computers. So really, 300 feet means it's going to work. Okay? We'll talk more about attenuation and stuff later, but at longer distances, one of those deals, it might work, might not. But 300 feet is going to work. Well, it should. Okay? All right. Here's a bus network. You've got a bunch of computers connected to a bus. You got a terminator on each end. What happens is the signal cruises out on the network, hits all the computers, and when it gets to this end, it just goes away. It's called the terminator. When I helped install a network at Tinker, we actually installed one of those in an area. It was that would be the northwest corner of building 230. They had 2 floors. They want it connected. Okay. How about the length on that cable? Anyone? It's 100 feet. It's wall. No. 10 base T. It's 100 feet instead of 300. Or whatever it was. The distance is a little bit shorter. But every time you had a connector, you got to subtract 15 feet. So basically, if you were limited to 100 feet, minus 15, minus 15, minus 15, because it takes up room. But I remember we ran this and we're like, this is too long. It's not going to work. Basically, we went up 1 floor, up, over, and then terminated at the far end, way over the limit. It did work, but again, there wasn't many connections at that time. But it's one of those deals. It would run slow. It would be intermittent. It's too darn long. You can't do this. Okay, then we got a ring, normally called token ring. What happens is the signal goes around. The signal, say it starts here, goes to this guy, says, hey, you need anything? No, good. You need anything? No, good. It continues around until somebody needs something. So one person can do something. Anyone know what those are good for? Actually good for banking industry. Think about it. If we look at a star or a bus, pretty much anybody can talk whenever they want. So what happens if I got Daniel over here in this classroom and Daniel won't shut up? What's going to happen to the rest of you? Are you going to be able to get a word in edgewise? No, because he's talking too much. Well, you could have that on a network. You'd have a computer talk too much. When they ring, everybody gets a chance. I say, do you have a question? Do you have a question? And we keep going around the room. So you know every so many whatevers, you're going to get a chance to talk. So that's why rings were better for banking industry. It was something that was time critical. Okay, so here's our star again. Everybody's connected to the center like this. We could have a hybrid, a ring with a bus, or a ring with a star with a bus. You could have a mixture of them. We actually have a star with a bus because we have a star in this room and port, which is it? One of the ports should be 24. I don't know, whichever one's 24. It's been a while since I made this diagram. Port 19, where the heck is 24? Well, port 24 should go down the hall. Port 22 is unoccupied. They have it crossed out. Well, that's nice. Oh, there, the 24 goes on 201. So really, this port right here, this yellow cable right here, is what connects down to room 201. It goes through that wall, across into 211, down over top of 210, into 200, then across the ceiling into 201. Because you got firewalls, it's a pain in the butt to get across. So really we have a star in here, but it's connected like a bus to the other building or other room. So again, there's no, it's what you normally see as hybrids. All right. The next thing we need is a protocol. A protocol is like a language. Does anybody know any languages in here other than English? Sign language? Oh, that'd be tough. That'd be, ooh, can't do it. Like reading lips? Nah, not doing that. I can't do it. But I know some Spanish. But do you think I know Spanish as well as English? No, definitely no. But some people do. What if I knew 5 languages? So what do you think would be more efficient? A machine that works with 1 language or 5 languages? Actually, I would tend to say 1. Because you know it really well. I mean, that's all you're focusing on. Because some words in other languages might be the same words, mean different things. So if you know 1 language, you're not going to have any issues. An example of that is a guy I used to work with referred me to a company called Aerospace Reports. Now the way up past Hefner Lake. But they did aircraft title searches. They're still in business today. One of my best clients. I had him forever and ever and ever. Well, he installed their network. He actually wrote a piece of software for them. Then installed their network. He said, Ken, I know nothing about networks, but I got it working. And he goes, I want you to take over the network. So he referred me to them. And I went out there, and the lady's like, all right, we'll continue. Our network's very, very, very slow. I said, well, let me look at it. And I looked, and he had every protocol installed. He had NetBEUI, TCP/IP, IPS/SPS, Apple Talk, everything installed. I'm like, dude, why? He goes, I don't know what they are. I just installed everything. And the machine was trying to talk so many different ways, it wasn't doing any of them really well. So I went to the owner, Vicky, wonderful lady, but I said, all right, I start remove. She's like, whoa, what are you doing? I'm like, I remove all this crap. You don't need all that. And basically they went from a big old list down to 1, just TCP/IP. And she was like, oh, are you sure? You've seen those people that they don't really trust you. But then once I did it on all the machines, I was like, oh, this place is working so much better. But a protocol is just a set of languages. That's all it is. Okay? It's a method of communicating, right? Format of communicating. So TCP/IP is what we use on the internet. We're actually going to have 2 chapters on that. It stands for Transmissions Control Protocol, Internet Protocol. And we know anything about it. Is it fast? Actually, it's quite slow. It's one of the slower protocols of all of them. So why would we make a worldwide standard of something that's slow? Everyone uses it. We're basically, other people presented different stuff, but everybody decided on this one. IPX/SPX, which is the Novell protocol, that can be routed, and it's super fast. No one liked it. NetBEUI, whole bunch faster than TCP/IP, but it's only for small networks. Apple Talk, well, Apple, so you really can't use it on other stuff. But whole point is protocols are very important, and whatever you decide upon, which nowadays you really don't have a choice, it's TCP/IP. But everyone needs to be on the same. A packet is a distinct data units exchange between nodes. Think about it. Like I went to the grocery store this weekend. Okay, I took that cart, drove through the store with my cart. I guess I didn't drive. I wheeled it. Filled it up with stuff. Then I went to the cash register. I went to the self-checkout. Darn scale kept screwing up. It was driving me crazy. But once I finally got it all done, what did I do with all my groceries? Did I stick them all back in the cart? No, I put them in little bags. That way I could carry them separately. That's what we're talking about here. We take our network traffic and break it up into little pieces in the packets. Say I want to I want to watch a Netflix video tonight. Okay? Am I going to be the only one watching Netflix in the world? Well, the only one on Cox in Oklahoma City? No. Can you imagine if I was? Because a network, we really haven't discussed this yet, but this network in this room can do one thing at a time. That's it. Only one person can talk at a time. That's it. We just do it so fast that it seems like we're all doing it at the same time. Even at Rose State, One computer on this entire campus can surf the internet at the same time. That's it. The fact we do it so fast, we don't realize that we're time sharing with other people. But, you know, what if I was the only one that could do Netflix in the entire world? And while I was watching Netflix, North America had to go offline and wait for Ken to finish. That was, it can't happen. So what we do is you break it up into pieces. You get a little teeny bit. Basically, 1,500 bytes is what you get. Very small amount of data, but we get them so fast we don't realize there are bunches of pieces of it. Okay. All right. So that's what a packet is. We take our stuff, break it into pieces. We'll cover more about that later as well. Addressing. How do we address to get there? I mean, you ever think it's pretty amazing how you can write an address on a letter? Like I mailed a bunch of postcards from Italy, which really sucked is I did a 12-day cruise. On day 2, no. The day before I got on the cruise, I mailed a postcard. Then I mailed the postcard pretty much every other day on the cruise. I got all the way back to Oklahoma, and the one that I mailed before the cruise made it back, but none of them that I mailed on the cruise made it back. It took forever to get here. But the cool thing was they made it. They had the Italian or Spanish postmarked, and they made it here. Croatian postmarked. So addressing works quite well. Okay. Same way on the internet. You can have a computer in China. How are we going to make sure we're connecting to the exact specific computer we need in a different country? Well, it's all based on addressing, specifics to the numbers. Right now we use IP version 4, but we're also converting to IP version 6. IP version 4, if we were to give an address to every person in the world, you'd get about 0.6 of one address. That's it. So if everybody needed one, just the people, you wouldn't quite get one. That's not taking into account all the computers on the network. We're just talking people. With IP version 6, there's enough addresses for every single person in the world to have 50 octillion addresses. We're talking millions, billions, trillions, 3 or 4 other names, and then octillions. That's a lot of stinking addresses. So that's how many addresses we have available now. Did anyone use a computer back when we had 640K in memory? Talking the old TRS-80. Actually, it was after TRS-80. Like the old Commodore 64s. That time period, remember that? I remember upgrading to 1 mega RAM. Then I upgraded to 2. I had to buy 9 separate SIP chips and a daughter board. Had to put them all in there and plug it in. Then I got a new computer. Then I upgraded to 16 megabytes of RAM. We're talking megabytes, not gigabytes. 16 megs of RAM cost me $600. See, I think I can buy a 2 gig flash drive now for like $14 or cheaper than that. Dell actually sent me about 40 of them for giveaways. And there were 16 gig ones. So it's just amazing how that's changed. The address space and the memory and all that stuff. Okay. Transmission media. That's this cable. When I learned networking back in the early 90s, I learned it at Landstuhl Army Air Station, Army Air Base. No, it's the Army base. Whatever, near Zweibrücken Air. There was whatever near Ramstein, Germany. I can't remember exactly what it was, but I remember learning that when he had 300 baud modems. We had a room set up with computers on one side, computers on the other side. It was the old big huge screens that were green and that's it. I remember we would type our message over there, walk across the room, and they would appear one letter at a time. We could walk there faster than the letters would get there. Then I remember the 2400 baud modem, the 9600, and then the 144s. Anyone remember those? Then we got the 56. Finally, we got up to 56K, and then we finally got good stuff after that. But some of you probably don't even remember anything but high-speed internet. So it's tough. I can't imagine living without it now. But the transmission media has changed. We went from phone lines to better quality phone. Like phone lines are actually Cat. Is it 2? Is it Cat 3? Okay. Yeah, Cat 3 is a phone line. We use Cat 5. Okay, or 5E, or 6, or even 7 now. So that's changing. Now we have wireless, which is just going crazy with the amount of stuff there. So if I have a wireless, and it's a G, 802.11G, what's that? 56 meg, is that right? So what's the fastest I can possibly transmit on a 802.11g with a 56 meg connection? It's actually half of that. Because wireless is a half duplex signal. Pretty much. What you basically say is, hey, I'd like to speak now. And the wireless device says, okay, Ken, you can talk now. And then I send my data. So I really had to send out 2 packets for every one. So even though you got 56, you're really only getting half of that. So, I had a T1 in my house. So, man, it's been a while. And I ended up getting 2 T1s. So 2 T1s. A T1 is 1.544 megabits per second. So if you get 2 of them, that's what? 3? Approximately? I think I got about 190K maximum throughput on a T1. Because the numbers are misleading. The way they actually work. I mean, when you see 1.544 megabits per second, no, it's not that. It is, but it's not. But we'll talk more about that stuff as well. But the transmission medium really matters. Okay. Here's our coax cable. Okay. I have coax cable in my house for my television. Actually, yeah, I do. I'm using it for my television. Okay. Here's our shielded twisted pair. That's not, well, okay, I guess they're calling that shielded. The picture's kind of weird, but so this is what we pretty much use today, but we really use unshielded. Picture the same thing without the shield. It's actually color coded. Is anyone colorblind in here? No one's gonna admit it. There's usually somebody that's colorblind because we're gonna make this cable, and they have to be in a certain order: white, orange, orange, white, green, blue, green, white, brown, and brown. And the problem is, if you do it in the wrong order, it doesn't work. And there's always somebody who has the hardest time. Then they finally at the end say, well, yeah, I really can't tell the difference between green and orange. I'm like, oh, thanks for telling me now. But if you have a problem with colors, let me know, because we'll talk about that. But shielded twisted pair. So why are they twisted? Does anybody know?
What keeps the signal from bleeding out?
It gets rid of crosstalk between the cables. Right, they're twisted differently. I think the orange is twisted the least. The blue and the brown are twisted more. And we're going to hear something called power over Ethernet. We have that here at Rose State. This phone, there's no power source plugged into it. It's plugged into the network only. But what it is, they have a power source at the switch. And it's using wires 7 and 8, which is the white, brown, and brown, to send electrical power to the phone. You can do that with your wireless devices at your house. Yeah. Roy down in my office, he actually made literal power over Ethernet adapter, because you could take your wireless device, you could literally have the power adapter in another part of your house, then the wireless device up in your attic with just one cable plugged into it and having power to it. So all kinds of stuff you can do with it. This is fiber optic. It's basically light. Okay. Imagine a light bouncing off. When I was building my house right in 2000, I wanted to have a smart house. I wanted to have all the cool stuff in my house. So I looked to get fiber optics. Okay? I did not get fiber optics. For 4 connections of fiber, it was going to cost me like $2,500 for 4. And actually, let me bring up a picture here. Let me show you. I don't know if I already showed you this, but
Is that to the house or throughout the house?
what?
Is that the connections throughout the house or to the house?
Actually, the connections are going to be throughout the house. The fiber was going to be.
You could have done it yourself for a lot cheaper.
No, that was just buying it.
Oh.
Yeah. Come on. But this is my house right here. Okay? The way I have it wired now, which is not the floor plan, but there's 4 bedrooms, an office, a living room, kitchen, all that stuff, and a garage. The way it's wired now, for that same amount of money, for the $2,500, I ran Cat 6 for the network, Cat 5 for the phone, RG6 for the cable, to 27 different outlets. Basically, every wall in every room has a jack in it. Because what would drive me crazy in the house? You want to put the TV there? Oh no, the jack's over there. So master bedroom has double of everything because you never know where you're going to put it. Like my garage has 4 I got connections in the laundry room. I got multiple in the kitchen. But I did it for $2,500, so it was kind of. But yeah, this is. I'll find a floor plan later on, but and my pool is blue now. It's not green anymore. case you're wondering. This is a long time ago. But this is where I ran my ISP, out of that shed right back there. Let's see if I can't. Actually, let me show you this. I know it's hard to see, but right there is a pole. That's what's called the D-Mark. That's where the phone company is. The phone line runs through the neighborhood right past there. And when they installed my first T1, it was in a bedroom here in the corner. So they came in through the D-Mark inside of my house right there. So they were going to run through here. Think that'd work out so well? No, you're not going to get anything. So they ended up going through the backyard. But, no, they were going to go through the backyard. That's right, they were going to. And I said, you know, there's a pole right there. Why don't you just come right down through here and connect? It'd be a heck of a lot easier for everybody. And Cox is like, oh, no, can't do that. Well, the engineers came out. You know, the guy came out and surveyed and says, we can't do that. But then when the guys actually came out to do the work, they're like, I don't know what idiot talked to you, but we're connecting out there. And I ended up getting multiple T1s, and no. So they actually, when they did it, they actually came through. There was a gate here. They came through here and connected in there. But when I got my other T1s installed in this building, I had the guy, I got to do a site survey again. They're like, oh no, we got to connect from here. So I said, you're literally going to come through my entire yard. I said, dude, there's a pole right there. Oh no, I can't do that. So then the guys actually came out to do it, and in the meantime, I had dug a ditch underneath the sidewalk and dug a ditch underneath the fence. I'm like, dude, I already dug the ditch there, I had a piece of conduit going up. And the dude was like, dude, that's amazing. We'll be done with this in 20 minutes. So they literally connected right into there. But I still have the other one connected in there. But turns out one of my students worked out there because it's actually connected through Dobson, which is McLeod telephone. But I'll tell you that story another time later. But he was telling them all about it. And they were like, oh, you're Kandui. Great, because my house, when I originally put my T1, I had 27 jacks. So they could just plug in here and instantly just jump the wires over and be connected in the bedroom. They didn't have to go up in the ceiling or nothing. I even ran the wires in a conduit out through the brick wall for them. I was ready. So when it was awesome. But yeah, that's what it looks like now. All right. So fiber optic, awesome, very expensive. That's what we have here. There's single mode, multi-mode. Talk a little more about that later as well. Very good, very fast. They really do not know the speed of it. You will see speeds, but I was reading an article about it when I'm working on my PhD. I was taking my PhD networking classes, and this guy working for Cisco was perfecting a new switching technology, and he was testing it with his mother living in Germany. Cisco's in California. He was testing with his mother in Germany. They perfected a technology using existing infrastructure to send a DVD movie 4.7 gigs in like 4 seconds. Can you imagine once that's actually out in the real world? If you can send 4.7 gigs in 4 seconds using existing wiring all the way to Germany, heck yeah, that's going to be sweet. So before long, all this broadcast television. Is there anyone here who does not listen to the radio ever? It's got to be somebody. The two guys in my office never ever listened to the radio. I still listen to the radio. But before long, the radios are going to be gone. The TV is going to be gone. Does anyone actually watch live TV? Really? Some of you do? You watch live TV? This is like 2012. I haven't watched live TV since 1999.
I just listen to football radio.
Online radio. Okay. And what did you say?
Football.
Waste of time. I record everything and watch it later on. Now I have a TiVo. If you ever know what TiVo is, oh, it's amazing. You just record stuff and watch it later on. But no, live TV, even when there was something I want to watch live, I hit record. I'd go dish dishes, do laundry or something for about 15, 20 minutes. And that, because I hate watching commercials. That way you could just catch up to the commercial, go zoom through the commercial. Then if I ever caught up again, I'd pause and go do something else in the house for a while. I can't stand. And the funny thing is, like, our secretary watches live TV downstairs, and sometimes she'll be talking about these commercials. I'm like, I haven't seen a commercial in about 12 years. Unless it's like a Super Bowl commercial that I watch online. Why bother watching the game? But I watch it online. Because you can find out who wins anyway. I mean, 20 minutes later, it's on the web. You just ask your phone who won the Super Bowl, and you know. So,
You don't get all the
Trust me, I get plenty of that. Plenty of that. I do enough cruises to make up for that. Okay. So, all right, let's move on. Then we have radio wave. That's our Wi-Fi. That is the most popular right now. More and more places are getting it. Before long, they're going to have free Wi-Fi nationwide. I mean, isn't it? I think Louisiana already has it, at least in the Katrina area. Google's starting to offer it in more and more places. So, before long, everybody's going to have internet. It's going to be free. So, it will be before long. All right, network services. Okay, first of all, there could be services provided. Maybe phone service, file sharing, could be email, could be printer sharing, internet access. We all use this kind of remote access capabilities. I can connect into Rosedace networks from my house. I can connect into my office PC. A lot of times I go on trips. I can connect in. Funny, I teach online for another school, Park University. And I had a student like 2 semesters ago messaged me, "Oh, I'm not going to be able to do any work this week. So I'm going on a cruise right now. Sorry, I'll submit it when I get back." I reply back, "I am currently on a cruise, answering my email. I don't think you'll have any problems at all." I was on a cruise ship answering his email. So, no, remote access, you can do it from anywhere nowadays.
He probably thought you were lying.
Yeah. He probably did, but I actually was. Actually, this last cruise, this 12-day cruise, was one of the first cruises in years that I didn't get the internet access. Other than when I stopped to get pizza or something, but because I didn't have any classes going on. There's always a class going on during my vacation, so I buy the $200 internet package or something, and figure like Park University pays me $5,000, so I can at least spend $200 on the internet. So works out pretty good. But remote access, awesome. You can do lots of stuff with that. Voice services, video services. Okay, voice over IP. We're going to be playing with a program in here called Kane. Anyone ever heard of Kane before? Awesome program. You can run Kane when it's connected to a computer that has a phone like this on it. Instantly records all your telephone conversations in MP3. We're going to play with that. It's awesome. This tool, totally free, and it's like so scary. Do not ever install it at work. You'll be fired. It can break passwords, capture traffic. It can do everything. Okay, network management is another thing. How do we manage the network? We obviously do that here at Rose State. So a lot of services provided. Okay. File server. Maybe we want to share files, share applications, share disk storage space. Okay. I have certain files that are kind of important, having to do with my grant. Do I store them on my office computer? No. I store them on our file server. That way they're backed up every single night. Have I ever needed one of them to be restored? No, but you never know. It could happen. For my house, or for my personal use, I have a service called Carbonite. I don't know if anyone's ever heard of it. It's called Carbonite. I pay $54 a year for unlimited storage space. And let me see how much I got right now. Let's get a new estimate. Carbonite.com. And let's see. Come on. Go. Well, why is it not letting me log in? There it goes. Yeah. Okay. Oh, I'm only backing up 195 gigs of data right now. That's a lot of stinking files. $54 a year. I'm backing up 181,000 files. See, I actually have this installed on my Office PC. And I have my Office PC and my work PC synchronized, so if I add something at home, it instantly appears in my Office PC, automatically backs up, and obviously was backed up today. And I have had to restore a few files from there. And what I like is you can actually go back a couple versions. Oh, darn it, I want to see that Word document 3 editions ago. But $54 a year? Yeah, it's worth it. But you can go in here and I could view files. Maybe. And I could go into my D drive. I could, all kinds of stuff. Somewhere I got my... And I actually have it backing up an external hard drive, which you can't do, but I figured out a way to do it. But there's all kinds of things you can do with it. So, kind of a cool program called Carbonite. If you don't have a backup system at your house, it's only days before you do get one because you're going to lose something someday and you're going to need it. Yeah, it's kind of cool to have. All right. So, the file services, especially when you have important stuff, you want to keep a copy of it. It could be application, disk storage space. Normally, a server has lots of storage space on it. Like Google. How much we all get with our free Google now? Like 7.5 gigs of space. Isn't that amazing? It's crazy. So, file storage, file server, the stuff we can do with files. And they talk about file servers are foundations of the network. Okay, fine, whatever. Print service, again, printing to a network printer. Like, there is no printer in this room. But I could print from this room. I could map to the printer down in room 201, print to it. Like, we have one color printer in this building. Well, for most people to use. I can print from my office to the color printer in the faculty lounge, get my stuff in color. So, do we really need a color printer in every desk? No. Okay. Alright. It says allow remote user network access. We talked about that already. You can connect from anywhere. Actually I haven't in a while, but in the past, the way I would do my email on a cruise ship, we use Microsoft Exchange here. We have an Exchange server, which some of you probably use the same thing. What I would do was I'd go in there and type all my emails, not being connected to the ship's wireless on the cruise ships. Then I'd connect to the wireless. Instantly, my mail server would download the new mail and send the outgoing mail. Then I'd disconnect. Then I'd go back to my cabin, read all the emails, write all the responses, get it all done, connect again real quick, synchronize the email. So I was really using no time at all on the actual Wi-Fi, but I was able to do all my mail. So there's all kinds of ways you can use this stuff. Okay. All right. Remote user, someone's connected in remotely. VPNs are used a whole bunch for that, and we're going to play with those too. Well, we'll look at one. We're not going to set any up. Not in this class. All right. Says access service provides LAN connectivity when WAN connections is not cost efficient. Rose State has an office on Tinker Air Force Base. I don't know if y'all know that. We also have an office on top of the bank in front of Mazio's. I think that's where Empower is now. But originally, when I started going to school here in the mid-90s, or maybe it was early 90s, Rose State had a dedicated connection to Tinker Air Force Base. That had to be expensive. They were the only ones that used it, big bucks. Now it's gone. Now we just have regular internet access. We use VPN. So instead of spending the hundreds or probably thousands of dollars for that connection, now they're paying 50 bucks. When I had my first T1 at my house in right around 2000, I paid 900 bucks a month for it, for one T1. So you know Rose State was paying more than that. So it's crazy expensive stuff. Okay? Alright, but it allows us to log in just like you're sitting in your office. Okay? Communications is convergence, is offering multiple types of communications on the same network. We can offer phone and data on the same network. Aerospace Reports, they built an office up on north side of Lake Hefner. When they were having the building built, they had me come in and install the wiring. And their ceilings are actually sheetrocked. So there's no fixing it after the fact. It was, you had one shot at this. Once they sheetrocked it in, you're done. So I basically asked the question using voice over IP. And their phone guy's like, nope, we're having phone lines or network lines and then phone lines. So I ran double lines everywhere. Group for the network, group for the phone. As soon as they're getting ready to move in, they get a better price from a different company, and they go voice over IP. So now I have double lines everywhere, and half of them aren't being used. But a good thing is, now they have redundancy. If one of the network line goes bad, they have a phone line sitting there that's not being used that they can just use as a network line. But yeah, like this here, this phone is actually over the same network as the regular network. So kind of cool. All right. Unify says centralized management of multiple network-based communications. They can take care of it. Okay, they can. I don't know. I can't think of another example for that one. Basically, they can just manage it from one place. They manage these phones from the administration building. They manage everything remotely. Well, they can. Mail server. I'm assuming we all know what email is. Mail server is, I would say, probably. It used to be file and printer sharing was the number one use of a network, and that's still the correct answer if you ever see it. But wouldn't y'all think email is probably pretty darn popular nowadays? Does anyone here have an email address? We all have one? Anyone have like 5 or 6? Yeah. Every time you get it, your job has one, you have one for home use, your school has one, and this guy has one. before you know it, you got 12 of them. So, all right. Additional tests of mail service, they couldn't interpret spam. We have a system here called Ironport, which is our firewall for the school. All the traffic comes through, but also does spam protection. And when I ran my ISP, I did a bunch of research on it, and 93, 94% of email was spam. This is a few years ago. It's probably worse than that now. But I still remember this one lady called me. She called me and says, "Ken, I got a problem." I'm like, "Okay, what's your problem?" She goes, "Friday when I went home, I had zero spam. I got rid of all my spam. My email was totally cleaned up. I come in Monday morning, I had 3 pieces of spam." I'm like, "Okay, this is unacceptable." 3 pieces of spam. I get 400 a day, easy. And she was griping about 3. It was crazy. And the way I explained it to her was, you go out to your mailbox on the side of the street. You know that thing we open up and the guy drives by, stick stuff in it. I know some of you probably haven't used it in years. But what do you get in there? Let's see. Yesterday I think I got a Kohl's, a J.C. Penney. I got 2 or 3 things that was pre-approved for some crap. So did I call all of them and complain to them? Actually, a lot of people, when they get spam, they reply to the spam. Is that a good idea? Oh, no, bad idea. Bad idea. So what happens is they send the spam out to everybody. Every name they can think of at every network they can think of. Guess what happens if you reply to it?
Lets them know that's
They're like, "Sweet, got another good one. Sell that baby right off." And instantly your spam quadruples. So what I try to tell people is, you walk out, like yesterday, I walked out to my mailbox, got my mail. Actually, I stopped on the way, driving down the street, grabbed it, pulled into the driveway, immediately walked over the trash can, opened it up, and threw them in the trash can. Did I sit there and call J.C. Penney and Kohl? No. So, but spam, there's lots of it out there. We switched to an Ironport system here, and I was so skeptical because my spam went from many to like none. I get like 1 or 2 a week now, and that's it. But the funny thing is, no one's ever complaining that I'm not getting their email. So obviously it's working. Because I was so worried, and instantly my spam went to 0 pretty much. I'm like, great, how many students are mailing me and I'm not getting it? But it's not happening, so I'm assuming it's working. All right, spam is a big issue. Objectionable content. That's tough. Like the word Viagra. How many ways do you think you can spell it? About 10,000. Try doing content filtering on stuff. It's tough. It's really hard. Okay, or web content even. I mean, you can run an ISA server, stuff like that. But handling objectionable stuff, first of all, to some people it's not objectionable. Do y'all know what the pornography policy is here at Rose State? As long as it doesn't bother any, we could care less. Kind of sucks. Because some people get very upset. But the way I had this a couple semesters ago, we had a guy in a wheelchair, nothing against people in wheelchairs, but we go in the computer lab in room 206 into the corner of the computer and turn his chair sideways for 20, 30 minutes, then he'd leave. Man, some people get very seriously upset with that dude because he would literally be removing clothes and the issue is, as long as it doesn't offend anybody, we don't care. It's that whole free speech thing, And it's tough. Try doing content filtering when you got a nursing program. You gonna filter out the word boobs? No, because they do research on that stuff. What? Assume they do. I'm not in the nursing program, but
Well, you would think they would call it something besides boobs.
well, that's true. Good point. Good point. Good point. They're like turkey breasts or something like that. But I was teaching at Meridian Technologies up in Stillwater for Terry Byer. Some of you might know him. He used to work up there. I was teaching an A+ class up there. And they have very strict content filtering because they have a lot of high school kids there. We were in there, and I don't know what we were doing. We were doing something, and then instantly our network was gone. We all lost internet access. Uh-oh, what happened? And someone comes, knocks on the door, pulls me outside. Yes, somebody over here was surfing pornography. I'm like, but it's tough. I mean, there is software out there to do it. It's just very hard to do. Okay, route messages according to rules. We're going to talk a little bit about ACLs in here. If not, you can take a routing class. Rule-based stuff is important as well. How about web-based clients for checking emails? Anyone ever check their email on the web? Thinking everybody was Gmail and Hotmail does. So that's another service. Notify administrator or users if events occur. When I ran my ISP out of that building in my backyard, I had a thermostat that was on the internet. Basically, it would message me. It would send me a text message and an email. Did it call me? It might have called me. I can't remember. If the temperature got too hot in my room. And I remember one day I went out there working in the yard, and my tractor was low on air, so I'm putting air in the tire, and all of a sudden I get a message from the server saying it's getting hot in here. And what had happened was I turned on the air compressor, which on the same circuit as the air conditioner. Then it flipped the circuit breaker on the air conditioner, so that's why I was like, what? I'm standing right next door. So I went in there, sure enough, the air conditioner was offline. But if they hadn't done that, guess what? My servers would have all been gone, everything else, because it's kind of important. We have that down the hall now, too. Was it a couple months ago, beginning of the summer? Our air conditioning here in this building is very old, if you don't know that, and it sticks. The damper sticks. In other words, if it gets cold at night, the damper will close. Then it'll stick closed. So the next morning when it starts heating up, it can't open. So we get no cooling air. Well, we came in room 201, was like 100-something degrees in there. Like, oh crap. I mean, you could literally hear the servers in that room in the hallway because the fans are going such a high speed trying to cool them down. So now we have a network thermostat in there that'll notify us. Okay, but also it could be for other stuff. People trying to break in, people doing whatever. Okay, you can also schedule email. Okay, communicate with other mail servers. Okay, they run specialized software, and I think we're about out of time, aren't we? Dude, your clock's still broken. 1 o'clock. All right. So I think we finished on 35. Yeah, we'll pick up on 36 next time. But we're going to finish it Thursday. So I might have to leave a little bit early Thursday, but we're going to finish one way or the other. All right, so you guys are free to go.